Hey, welcome to an all-new lesson for Algebra 2. Today we're going to look at another type of factoring here, and we're also going to look at doing stuff with polynomials, adding, subtracting, multiplying. So we've learned on Wednesday a couple different types of factoring. On Wednesday we pulled out a GCF. Okay, we're always going to start with that. And then on Thursday we learned a couple different types. We learned trinomials. We've done plenty, but we practiced a lot with those. And we also did grouping. Okay. Remember, grouping is what we do if we have four terms here. We're going to learn another type today with two terms. All right, here we go. And one more thing. Remember, factoring means multiplication. We're turning something into multiplication, okay? So think multiplication. On this page, you'll see a lot of stuff, but one thing you'll notice is we have a binomial, right, in the light blue here. Bi, it means two. We have two terms being added or subtracted. And then on the other side of the arrows here, we have the factored form, right? X plus 7 times x minus 7. X plus 12 times x minus 12. 2x plus 3 times 2x minus 3, etc. What patterns do you notice? All right. A couple things you could have said. You could have said that when we have binomials, there's no x term or y term in the middle, right? You could say when we factor it, we get the same thing, just opposite sign, the conjugate. Keep that pattern in mind because that's really going to help us as we go through these today. This is called difference of squares, okay? We have a pattern that looks like this, a squared minus b squared. And if we have the unfactored form of a squared minus b squared, we can factor it by doing a plus b, a minus b, okay? Different signs. You should notice a is just the square root of the first term, and b is just the square root of the second term. All right. Difference of squares. Now, here's the thing. A squared and b squared, these have to be perfect squares because we have to be able to take the square root. So keep in mind, here's a table down here of perfect squares that we know, okay? This table here, we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are perfect squares. Those are numbers that we can take a square root of, okay? All right, let's take a look at what this looks like here. Okay, 9x squared minus 25. From now on, you see two terms. We're going to look and see, hey, are these perfect squares? 9, 25 looks good to me, right? So all we need to do now is turn that a squared minus b squared into a plus b, a minus b. Okay, now to find what a and b are, here's what we're going to do. So we have one where we're adding, one where we're subtracting. Remember, 9x squared is a squared. We're just going to take the square root of that. So the square root of 9x squared is just 3x. Okay, 3x. So we have 3x here and here. And then the b term is 25. The square root of 25 is just 5. So I have plus 5 minus 5. And this makes sense if you FOIL it back out because these first two terms multiply to 9x squared. These last two terms multiply to minus 25. And the only way we're not going to get any x's in the middle is if we have plus 15x minus 15x. If those terms are exactly the same so that these go away. Okay, so if we factor this back out, FOIL it back out, we get 9x squared minus 25, that original thing. Okay, let's try another one. Oh, actually, let's fill this in. Remember that guy? He's telling us what to do here for factoring. This is a table you started last week. I'll provide another link to it if you didn't get last time, so if you can print it. If you can't print it, just copy these notes. These are going to come in handy as you factor. So we've done 4 terms, we've done 3 terms, now we're doing 2 terms. Okay, if we have 2 terms, we're going to look at difference of squares, this is called. So difference, let me make this smaller. Difference of squares. All right, where we have a squared minus b squared. A couple things. A and b have to be something you can take a square root of, and this is only difference, okay? Only subtraction. Subtraction. All right, if you do that, this is what that pattern looks like. It says if you have a squared minus b squared, to factor it, we can turn that into a plus b, a minus b. Okay. An example would be x squared minus 9 would turn into x plus 3, x minus 3. Okay, or you can put the one we just did in there. All right, copy that down, use it, remember it, practice it, get familiar with it. Here we go. All right, factor completely. Let's take a look at this one here. X to the fourth minus 16. Okay, x to the fourth, when we're dealing with powers of x, we're looking for things that are divisible by 2. Okay, so we're looking for even numbers. X squared, x to the fourth, x to the sixth. And then 16 is definitely a perfect square. So to do this, we're just going to take a look. And we're going to take the square root of this a term. Now, the square root of x to the fourth is just x squared, because when these multiply together, x squared, multiply together, we get x to the fourth. And then these two need to multiply to 16. So we just have plus 4 minus 4 factor. All right. So it's pretty simple once we identify that they are perfect squares. It's not too bad, okay? All right, 8x to the third minus 32x. Now, 8 and 32, those weren't on my table at all, right? I don't see those as perfect squares. Up here, I don't see those, 8 or 32 anywhere, but here's the thing. Let's take a look for a GCF. Sometimes our patterns are hidden until we take out a GCF. Okay, 8 here, I want to see if I can pull out an 8 from 32, and I can because 32 is divisible by 8. So I'm going to pull out an 8 as a GCF, and then I have 3 x's and 1 x. I can pull out the most amount of x's is just 1 x. Now, if I do that, remember, it's like dividing each of these terms by 8x. So 8 divided by 8 is 1. X to the third divided by x, I'm just left with x squared. Negative 32 divided by 8 is minus 4. And x divided by x is no x's, okay? All right, at this point, I said factor completely. We should recognize now 2 terms here, x squared minus 4, is definitely a difference of squares. So keep that 8x, that's part of our factored form. And this binomial here, I'm going to turn into a difference of squares. So xx plus minus, and then 4, what's going to multiply to 4? Just plus 2 minus 2. All right, and again, if you FOIL this back out and then multiply by 8x, you're going to get that same 8x cubed minus 32x. But this pattern helps us factor it nice and easily. All right. 4 terms. You're like, hey, Mr. Miller, I thought we were doing 2 terms today. And I'll get to that in a second. But I say factor completely. When we factor 4 terms, we're always going to do grouping. All right, buddy system. We need to group together these first 2 terms, group together these last 2 terms, and let's take a look because this one, you'll kind of see where we get with it. All right, the first 2 terms, I have a 16 and a 48. 16 actually goes into 48, so I can pull out a 16, and then I have 3 x's and 2 x's. Oh, I can pull out 2 x's, and if I do that, I'm left with x minus 3. Keep this sign, keep that minus sign, okay? Now, GCF between x and 3, not much to work with, but I need to pull out just something, okay? I'm going to pull out a minus 1. Now, this one's a little tricky, but if you do divide both of these terms by negative 1, the signs are just going to switch. So I have negative x divided by negative 1 is x. 3 divided by negative 1 is minus 3. At this point, we've gotten pretty good with grouping where we should know that we should have those same things in the groups, right? X minus 3, x minus 3. If you don't, go back, you did something wrong, okay? All right, group together, we have 16x squared minus 1 times, let me give parentheses, x minus 3. All right, now, I said factor completely. Do we see anything that we can continue to factor here? Sure we can, right? 16x squared minus 1, those are perfect squares. So I'm going to keep going. 16x squared minus 1, I'm going to factor, and that x minus 3, I'm just going to keep there. We can't do anything with that, but 16x squared minus 1, these first 2 terms I need to multiply to 16x squared. So I'm going to have 4x and 4x, right? The square root of 16x squared. These two have to multiply to 1, so I'm just going to have plus 1 minus 1. All right, so there we go. Always check to make sure you can go farther, because as we get more complex problems, we're definitely going to be able to continue, okay? All right, so from that original thing with 4 terms, and again, you might see it's not factored, right? We just have terms being added or subtracted here. We've turned it into multiplication, okay? Something times something times something. That's really helpful when we start to graph these to see where those zeros are. All right, enough for factoring. We're going to leave that behind for now. We're going to take a look at our next lesson, which isn't too bad. We're going to add, subtract, multiply polynomials. Okay, again, polynomials, many terms. So these are many terms together. Okay, perform the indicated operation and simplify. Be careful here. When I say operation, you have to look at what I'm asking you to do. There's a plus sign, so I'm asking you to add these terms plus these terms. That's all we're doing, is just adding these together. So there shouldn't be any multiplication involved at all, okay? When you're adding, I just drop the parentheses and I just go x plus 1 minus 3x squared plus 8x plus 21x squared minus 1. At this point, again, no multiplication, we're just adding and combining like terms. So you can rewrite this in any order that you want. I'm just going to leave it in this order, and I'm going to just scoop up like terms. So in the orange, I have negative 3x squareds plus 21x squareds. Okay, x squared are like terms, so I have negative 3 of them plus 21 of them. I have 18x squareds. All right, next like terms, let's go in the blue. Again, I'm doing it in order just so I can put it in descending order as I go. But I have x, or 1x, plus 8x's, so I have 9x's. And then I have in the red, my constant, I have 1 minus 1 is just 0. And since I don't have to write that at all, okay? Make sure you get all your terms. I've scooped up all my terms. At this point, that's my answer, okay? Now, you might want to factor this, right? You're like, 2 terms, I could pull out a GCF. I'm not asking you to factor, okay? I'm not asking you to factor at all. I said perform the indicated operation. I just said add these together. Stop right there, okay? All right, addition, easiest. Subtraction, we're moving up a little bit, a little harder here. Subtraction, okay? Again, all we're doing is asking you to subtract these terms from these terms. That's it. You got to notice that subtraction sign in the middle. All right. Again, the hard part with this one is we need to subtract each of these terms at the end. So we need to distribute this negative sign, or this negative 1, to each of these terms, okay, to make sure that we're subtracting them. So I'm going to clear out the parentheses. I have 9x minus 12x to the third minus 5x to the third, right? Because I'm subtracting each of these terms. So minus 5x to the third, and minus 7x, and minus 2. Minus negative 2 turns into plus 2. So remember, when we're subtracting, it changes each of the signs in the parentheses. Okay, same thing as before. Now we're going to scoop up like terms. Negative 12x to the third minus 5x to the third is negative 17x to the third. Let's do our x's next. I have 9x minus 7x, so I'm left with plus 2x. And then I have, let's choose green, just a plus 2 hanging out at the end. So that is my answer. Multiplying polynomials. All right, just a little background before we start, because it's going to get a little crazy. If we have x times x, we have x squared, right? If we have x to the 4th times x to the 6th, we have x to the 10th. And here's why. If we have x to the 4th, that's like x times x times x times x. And then if we're multiplying that times x to the 6th, that's x times x times x times x times x times x. All right, if you're multiplying these together, how many x's do you have? You have 10 x's. So basically, when we're multiplying powers here, we're just adding up those exponents, okay? So we have x to the 10th. And same thing over here, x to the 1st times x to the 1st is x to the 1 plus 1, which is just x squared. All right, keep that in mind as we take a look at something like well, this, but not too bad. All right, multiplying, okay? We have 2x next to parentheses, that means multiply. So we need to make sure we distribute this in. 2x times x is 2x squared. 2x times 3 is plus 6x. There we go. Kind of like the opposite of factoring out a GCF. Now we're multiplying back in. All right, that was a baby step into something like, still holding out on the good stuff. X minus 2 squared. When we're squaring something, that means we're just multiplying it by itself. And we're foiling out, right? X squared minus 2x minus 2x plus 4. Scoop up like terms, and those middle terms are always like terms. We can do something with them. X squared minus 4x plus 4. Okay, we're just expanding that. All right, here we go. I promise you good stuff. We got some good stuff. Here we go. Now, here's the thing. When we have trinomial times a trinomial, we're going to have 3 terms times 3 terms. We're going to be left with 9 terms. So if you FOIL this, really it's not FOIL. It's really first, middle, last, outside, inside, second. Like, it looks like this, right? First term times everything. Middle term times everything. Last term times everything. It's messy. So here's what I recommend doing. We're going to make a nice little box to kind of organize our terms, okay? That first trinomial is going to go on top. Doesn't matter, actually, but x squared plus 5x minus 1, I keep those signs with it, times x squared minus 2x plus 4. This kind of ensures that each term gets multiplied by each term. All right, I'm going to leave nice little boxes here for it. Now, I'm just going to multiply each of those terms into the box. So I have x squared times x squared. We're going to add those coefficients. So we have x to the 4th. Now I have x squared times 5x. And I'm going to put in this box. I have 5x to the 3rd. Basically, we're just counting x's, right? We have 2 of them and 1 of them. So we have 3. And then I'm going to multiply x squared times minus 1, which is just going to change the sign to minus x squared. All right, we're going to keep doing that. Let me get rid of those colors. You know the pattern now. Negative 2x times x squared is negative 2x to the 3rd minus 10x squared. Negative 2x times negative 1 is plus 2x. 4x squared, 20x minus 4. Now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, which we need to write out and combine like terms, but it's a little easier than that because you can see a pattern kind of evolving here where this square here is my only x to the 4th. All my x to the 3rds are diagonal to each other. So I have negative 2 plus 5 is plus 3 x to the 3rds. Now my next diagonal are all my x squareds, right? So I'm just going to combine these like terms. I have 4x squareds minus 10x squareds minus 1x squared. So I have 4 minus 10 is negative 6 minus 1, negative 7 x squareds. And then I have all my x's are right here, 20 plus 2, so I'm left with plus 22 x's. And then all by itself is, where's my last card? There's an orange, minus 4. Oh no, minus 4. Orange, okay, got to make it look nice. All right, my coefficient at the end is minus 4, my constant, okay? So we multiplied, we kept it nice and neat, we combined all like terms. It's a little messy, but that's what we got to do when we're multiplying 3 terms by 3 terms. All right, let's take a look at one more here. I definitely recommend that area model to keep your work organized. So 4x squared plus 3x plus 2, 3x squared plus 2x minus 1. All right, and you're doing 2 things here. 4 times 3 is 12. X squared times x squared is x to the 4th. Okay. 3 times 3 is 9. X squared times x is x to the 3rd. So again, always do multiplication though too. We're not doing addition. A lot of times someone in like just one box will add the terms. We're not doing that, okay? So let's fill this in. All right, at this point we have our pattern here. We have 12x to the fourth. We have 17x to the thirds. We have 6, 6, and negative 4. We're left with 8 x squared. We have negative 3x's and 4x's, so I'm just left with plus 1x or plus x. And then my last lonesome negative 2 here. All right, so a little tedious, but just be precise with your work. You'll be fine. We're learning a lot of stuff, but you're doing good. Thank you for being patient and such great students while I wasn't there last week. Moving forward, if you have questions, you need to step up and ask questions, okay? Come back into the Google Meet at any time. Let me know what you need help on. Otherwise, I don't know where to help you. So come back into the Google Meet. I think we'll have an exit ticket and some homework to get started on. See you soon. Bye.